In this video, we'll get started using the Azure AI Speech Service REST API to create a batch transcription job. And we'll see how to enable and configure speaker diarization. This will start the job and return a job ID. In later videos, we will use that ID to get the status and results of the batch job. Before using the REST API to transcribe the audio, I need to make it available to the Azure AI Speech Service. The easiest way to do this is a publicly available URL. If you need to secure your recordings, it is possible, but that's beyond the scope of this demo. Instead, for this demo, I'll be using an Azure Blob storage container with public anonymous read permissions enabled. After I upload the audio file to the container, Azure will provide a URL to access it. Now we can open up Visual Studio Code. There are two packages that need to be installed with pip: requests and python.env. The request package will be used to make HTTP requests to the endpoints of the Azure AI Speech Service REST API. The python.env package makes it easy to configure environment variables for a project. For this demo, I'll want to store the API key, blob URL, and endpoint as environment variables, and I'll be able to put them in a .env file that will be loaded when the application starts. More about that in a second. First, let's get the API key and endpoint from the Azure portal. From the overview page for the Azure AI Speech Service resource, expand Resource Management on the left side. Click Keys and Endpoint. Again, to access the Azure AI Speech Service via the REST API, you'll need to store one of the two API keys from this page, and you'll make requests to the endpoint at this URL. Back in Visual Studio Code, I'll create the .env file. Inside, I'll add key value pairs for the environment variables. First, the API key, which I'll fill in off camera. Next, the base URL for the endpoints. Note that I've added the path speech-to-text v3.2 transcriptions to the endpoint from the Azure portal. All of the endpoints we will use in this series will use this as a base endpoint. And the blob URL that I'll also fill in off camera for security purposes. I'll create a new file named main.py and import the OS module from the Python standard library and the request module. And I'll import the load.env function from the .env module. Call the load.env function to load the environment variables from the .env file. The environment variables can now be accessed using the OS module. I'll create a dictionary for the headers. The REST API expects all requests to be authenticated by passing the API key in the OCP-APIM-subscription-key header and set the content type to application/JSON. Now we can configure the body of the request to the REST API. This will be a dictionary that requests will convert to JSON. First is a list of URLs for the audio files to be transcribed. Next is the locale and a friendly name for the batch job. Now we can enable diarization in the Properties key. Also, add a Speakers key. Set the min count and the max count to 4. And with that, we can make a post request to the REST API to start the batch transcription job. The headers and JSON keyword arguments are set to the headers and body dictionaries, respectively. This will kick off a batch job, and if successful, return a response with a 201 status code. The body of the response will be a JSON object. Let's take a peek inside. As you can see, there is a considerable amount of data about the job. Fortunately, all we need for this demo is the self key. The last part of the endpoint is the ID of the batch job, and we want to extract that. We will use the ID in the next video to get the status of the batch job. And that's a good stopping place for this video. In the next video, we'll see how to poll the REST API for the job status. Once it completes, we will be able to retrieve the results and extract the transcript with speakers. Again, this video is part of a series. If you want to follow along, be sure to check out the YouTube playlist linked in the description. Thanks for watching.